Assalamualaikum. Welcome back to Artificial Intelligence, and in this video series we're going to cover on the topic of reinforcement learnings. We're going to look at what is the definition of reinforcement learnings and what are the main components of RL, and we're going to see some of the examples and where to apply these methods. Let's begin. Okay, before we go in details into what are reinforcement learning, first we're going to take some overview on the definition of learning itself. Okay, so I think you guys already have the basic understanding what it means by uh, learning, right? So basically, what we already know that we have two types of learning, which is supervised learning and also the unsupervised learning, right? We already understand that supervised learning means that you have an AI that we we need to train them with the specific set of data lah. Alright, so for example, if you want the AI to recognize, for example, a human, right? So you have to have a set of training data that shows the shape of a human, and the AI's algorithm will recognize that shape. And when we use that AI algorithm to some object, for example, right, and the AI going to able to classify that object as human because we already have trained them with the human shape data lah, right? Uh, as compared to unsupervised learning, usually we don't have any feedback on the learning itself. So what happen is the AI algorithm categorize some of the object into some category that we set some of the category that we give task to them lah, right? So that's two type of learning so far. But in reinforcement learning, right, it's not too different between the previous one, because in reinforcement learning we actually let the AI to learn by their own experience, right? For example, kita pergi kedai makan kan, and then uh, the only way we know that the kedai makan tu ada makanan yang sedap is by trying it, right? Bila kita duduk situ and then we order makan and makan, oh, okay, this kedai ada bagi makanan yang sedap, right? So immediately when you taste that food, then you know that the food is tasty. That is an immediate reward. That is not learning yet, but we have imagine that you have another set of memory that you store. Okay, this particular restaurant have tasty food, and you learn that the next time when you go when the next time when you want to find a restaurant to eat, then you already know, dalam kepala kita dah tahu, oh, this kedai ni sedap, and then you're able to bagi tahu orang lain, okay, ni kedai sedap. So that is one of the simple example lah on what learning means kan, for in this case. Alright, so basically, in reinforcement learning in RL, we have to deal with the agent that able to sense and act upon the environment. So macam case tadi, kita kena ada ability untuk sense lah, kita ada ability untuk evaluate makanan tu sedap ke tak, tempat tu best ke tak, how good is the reward when you given a decision kan. Kalau act upon ni maksudnya, kalau macam case restaurant tadi, you decide to go to there, so you have ability to act upon to the environment, and then you able to taste the food. So that is the that's what the intelligent agent means, right? So in the previous lecture, I think you already cover this. So you have to have a perception, and all your agents should have act upon to the environment, right? So this kind of application, you can actually apply RL in a lot of situation lah. So for example, you can have a robot cleaning, robot cleaner, right, like a robot vacuum, right, able to sense where is the dust, and you have robot soccer. I think this one you already did in the previous POPBL. What are the fitness or the objective function that you're able to uh, set to the robot, so that the robot can learn their way through the game kan. Contohnya robot soccer ni mesti score goal. Kalau goal lagi banyak, lagi bagus. So that is the objective lah. The objective should have more goal. For example, you set before that you should have the robot should have more possession to the ball kan. Kalau nak goal, kalau tak dapat bola macam mana nak goal. So dalam you punya AI tu, you dah setkan supaya robot tu mesti selalu dapat bola contohnya. So that is some of the objective function or fitness function or cost function that you engineered or you design to the certain intelligent agents, right? So banyaklah contoh-contoh lain lagi. I hope you guys can provide the more examples lah in the POBBL. Okay, so so basically what is learning? So macam kita dah cerita tadi, is actually learning can only take place bila an agent, right, the agent have the interaction with the world lah. Kalau intelligent agent tak ada interaction, so there's no learning happen in this case. Okay, so the keyword is should have the interaction of agent and the world, or the environment, right? And then the learning takes place, they have some sort of the memory lah inside kan. Dia kena ada memory, dia ada tempat untuk store whether the certain decision tu is good for them. So next time they doing it, they already know. Okay, kalau nak sampai ke this objective, you have to go through this set of decision, right? Ni kita dah cover tadi. So the bigger picture is here lah, right? Kalau if you learn before this, your intelligent agent only provided by okay, given action, and your intelligent agent give an action to your environment, and your environment will give the only state kan. But in reinforcement learning, it's also have what they call as a reward lah. Reward ni yang menyebabkan your agent ni could learn new things about their environments. Okay, so basically kat sini cakap your action influences the state of the world which determine the reward. Ni samalah case macam ni kan, cuma dia punya gambar dia lain sikit. Okay, tak apa, there also in any solution there must be a complication lah, tapi ini tak apa. Okay, now we go to the reinforcement learning, right? So in reinforcement learning, basically apa yang kita nak achieve, apa yang kita nak our intelligent agent able to achieve is to learn how to behave successfully. Okay, how to behave successfully to achieve a goal while interacting with the environment kan. So basically kalau macam our AI before this, kita just pilih what is the best decision kan. In contohnya, kalau nak pergi from point A to point B, okay, what is the best selection of destination kan, right? Ada beberapa destination, and then they go through macam you use breadth first, and you use macam apa nama, a lot of other types of solution lah, right? So tapi dia tak ada store any memory on what is the best path. For example, kalau from point A to point B, before this kita tak ada save mana path yang the best by doing repetitively kan. Kita just go through with all the decisions and then we decide on the best outcome kan. So the main difference is now we have what they call as experiences lah, senang cakap lah kan. Bila dia lalu from point A to point B, first randomly kan, dia pilih je mana-mana laluan, bla 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 bla, and then dia dapat satu value, and then they already know, okay, dia akan store this path, give you a certain value. And then dia try lagi, dia try lain path, and then they give us different value. Bila kita gunakan jalan ni banyak-banyak kali, so macam human lah, kalau kita dah lalu banyak-banyak kali, then at the end of the day kita akan tahu, oh rupa-rupanya this one path is the best. So that's what the beauty of RL, that you can teach how you can let your intelligent agent the ability to learn from their own experience. Okay. So ni ada contohnya lah kat sini. Ada game playing, so player know whether it's win or lose, but not know how to move at each step kan. So dia akan main banyak-banyak kali, so dia akan dapat that experience, and then they know how to win kan. Macam main card ke, main Uno ke kan. So lagi apa, traffic system, measure the delay of car but not know how to decrease it kan. Contohnya kalau macam ni, dia ada a lot of input from the system kan. Dia tahu kereta tu berapa slow, berapa laju, tapi macam mana dia nak tahu macam mana dia nak reduce the delay itself. So it's through the learning process lah. Tapi macam mana kita nak buat tu. Tapi contoh ni contoh yang kompleks lah kan. Tapi biasanya anything complex, we should start with the simplest form. Okay. Kalau contohnya kita nak buat AI untuk chess. Chess tu kan dia punya piece dia ada banyak, and then movement dia ada banyak, and then dia punya location dia ada banyak. Macam mana kita nak simplifiedkan that situation into the simplest form. So basically apa yang kita buat ialah kita reducekan lah dia punya step ataupun decision tu. Okay. Alright, so main point is for RL is kita nak we want the intelligent agent to learn the optimal policy that maps state to the world of the action of the agent. This is the technical terms, right? So for example, we have something like this, kan? You have macam kita cakap tadi, kita simplifiedkan kita punya decision. Contohnya kita ada grid macam ni. This is your starting point, and then this is your goal, right? So your intelligent agent, kita nak intelligent agent kita move to the goal. Tapi our intelligent agent ni dia tak ada sensor, dia tak ada apa, dia cuma tahu moving forward, left, backward and right kan. Dia nak boleh lompat to the next box ni. So kalau untuk contoh macam ni, kita nak supaya this agent kan, this intelligent agent learn the optimal policy. Maksudnya optimal policy tu kita nak supaya kita punya intelligent agent ni jump straight forward to the goal lah kan. Kita tak nak dia pusing, which is require a lot of steps, right? So macam mana kita nak agent ni ada the optimal policy. Maksud optimal policy ni combination of movement lah. Kalau contoh macam ni, the combination of movement dia ialah right, and then upward kan. Right, ni masuk sini right, ni masuk sini right, and then dia upward. This is the optimum policy. Ini kita tahu sebab kita tengok gambar rajah ni. So you imagine you are the agent inside here and you are blinded, you tak ada sensor, you tak ada apa-apa. Tapi apa yang you tahu ialah bila you dapat masuk goal ni, you are given a certain reward. Macam you dapat dapat RM10, dapat RM100. Bila sampai goal dia dapat some reward. Itu je yang kita tahu. So macam mana kita nak hasilkan, kita nak belajar melalui that experience is by kita keep on trying all the path lah. Tapi at the end of the day kita nak hasilkan satu ability untuk, ataupun ada satu table yang kita refer, this is our experience before this. Okay, tak apa, kita akan tengok on the next slide. Okay, so basically apa yang this equation say is that kita nak optimal, pi ni is the optimal policy. Kita nak polisi yang terbaik berdasarkan state of the world, yang map state of the world based on our action. So ni action lah, action kan, banyak kita punya action to the world, and then state from the world ni, bila kita do some action, kita akan berubah kita punya state. Contohnya kalau kita move right, kita punya lokasi akan berubah, our state of the world akan berubah. Alright, so bila kita dah tahu tu, right, now next kita nak tahu macam mana kita nak let the intelligent agent evaluate the value or evaluate the feedback from the world, kan. Bila buat satu decision tu, nak tahu benda tu bagus ataupun tidak, dan macam mana that intelligent agent store ataupun simpan that particular information, right. Untuk ni kita akan continue to the next video. Jumpa lagi in the next video. Assalamualaikum.